Hello everyone. In this short video, we will use Excel to conduct a proper hypothesis testing for the mean. Let's get started. In a nutshell, by using Excel, we will conduct a two-tailed test on the population mean. We will calculate the test statistics and the p-value, and based on the significance level, we make a decision on the null hypothesis. We will work with North Carolina 2004 birth data. We have 998 observations and 13 variables. We will focus on weight variable specifically. North Carolina being the population, the statement we will be testing is that the population mean has a birth weight of 7 pounds. We have a sample with a mean of 7.10 pounds, and we have newborns with weight as low as 1 pound all the way up to 11.75 pounds. This is a left skewed data with a negative skewness number, and a median is being higher than the mean value. We are conducting a two-tailed test as the null has equal sign. In a two-tailed test, all we want to do is to show that if the null is true, then having a sample mean of 7.10 pounds will be very unlikely. In other words, we will calculate the probability of getting 7.10 pounds sample mean under the assumption that the null is true. For that, we need to look at the sampling distribution of sample mean. More on this later on. If it is very likely in such a way that the hypothetical value and the sample mean are close to each other, then we do not reject the null. How do we decide on how far is the observed differences? We use the critical value to decide. We will first calculate the test statistics and then calculate the critical values for the test statistics. We pretty much draw the rejection and non-rejection regions. Now we will use Excel to calculate all and make a decision. Now we will use Excel to test the null hypothesis that the average newborn weight in North Carolina is 7 pounds. That 7 is coming from our null. And we have the sample statistics. We have a sample of 998 observations with a sample mean of 7.1 and a sample standard deviation of 1.51. And also in here we have the level of significance 5%. This is the type 1 error. We are okay with that. This will be needed when we calculate the p-value, when we make the decision about the null hypothesis. Let's go step by step to calculate necessary statistics and then make our decision at the end. We're going to start with the standard error of sample mean. We just get one sample, and this is a random variable. Those statistics are random. Like if we get another sample, we get a different number. What if we do this millions of times? Each time we have 998 observations and calculate the sample mean, what will be the standard error? The formula is, since we don't know the population standard deviation, we rely on the sample standard deviation and divide by the square root of n. This is the denominator in our test statistics. So if we keep doing it many times, on average that is the standard error of sample mean, like 7.10. So it will have that much of deviation. Degrees of freedom, since we don't know the true distribution of newborn weight, we are relying on t statistics and t-distribution, student t-distribution. And for that, we need the degrees of freedom, and the formula for that one is n minus 1. That will give you the degrees of freedom. This is the variable we're going to use to calculate p-value in this practice. Now, let's calculate the test statistics. The formula is given in here. Test statistics, pretty much what we do, we look how much is the distance between the sample mean and the predicted value, and divide by the standard error of the sample mean. Pretty much we standardize it. So let me write down the formula first. We get the sample mean, subtract the hypothetical value, population mean, and divide by the standard error of the sample mean. So we get a number 2.09 in a student t-distribution that is the value on the x-axis. So what we're going to do, we will first calculate the critical value. Again, it is not necessary, but I'm going to show you two different ways to make a decision. One of them is a critical value. For that value, we're going to just see in a t-distribution what will be the area for that given test statistics. For that reason, we're going to use a t inverse 2t function. Since we are having a two-sided test, we're going to use 2t function, and inverse will give you the value on the x-axis for a given probability. Our probability is 0.05, and our degrees of freedom is provided in here, 997. So this is the critical value, and this is the test statistics. So one way to make a decision by using the critical value is to see whether my test statistics is above, in absolute value, above a critical value. And apparently it is the case. So we reject the null. We reject the null of mu is equal to 7. Why? Because critical test statistics is higher than critical value. This is one way of making a decision after conducting this proper test. Another approach is to look at the p-value. So for p-value, there are two different ways to calculate the p-value. I'm going to show you both of them. One of them is t-dist 2t function. So what we're going to do, we are going to, for x, we're going to introduce the test statistics and enter the degrees of freedom, and it will give us the p-value pretty much for a t-distribution. That is the area to the right of 2.09 and to the left of minus 2.09. So the total area is 0.036, like 3.6%. Another method is to just calculate the one side in the t-distribution and multiply by 2, because we are conducting a two-sided test. For this one, we're going to use t-dist right tail. We enter the test statistics and the degrees of freedom, but this time what we're going to do, since we are conducting a two-sided test, we are going to multiply by 2, because otherwise it is going to give you only the area in one tail. So as you can see, like the numbers are exactly the same. In two different ways, we get the p-value 0.03. Now, time to make a decision. Are you going to reject the null or do not reject the null? What we're going to do, if you want to use the p-value, we're going to compare the p-value with the level of significance. Okay, given that our p-value is less than the level of significance, we reject the null. So we reject the null. Why? Because p-value is less than the level of significance, which is alpha. In other words, we have very low p-value, which means if the null is true, having a sample mean of 7.1 is very unlikely. We shouldn't have it. So we reject the null. So I hope it will help you to make a decision. And if you have the setup, you can test anything, any value. Like you can just, let's say that make it to 6.5 and then change only this value, and then you will get the corresponding value. Let's see what's going on. B7 minus B. Oh, I need to put it 0.5. So you can easily test any null value and then make the decision accordingly. Apparently 6.5 we reject because test statistic is very high, way bigger than 1.96. Hope it will help you to work on problems looking for two-sided tests as shown in here. Thank you for listening.